recording.
Okay, so I'm recording, and like, if you are ready, we can start. So let me just check, because if I have all the questions you gave me, I think I do.
It was a bit of a brain dump in like 10 minutes. So it's, no, not even 10 minutes. So if you want to ask other things or you don't want to ask those things, it's totally fine.
So why don't you have robots at home? That's the question.
They're all in the lab. That's why, because they're big. They're big. But they're not, some of them are small, but then other people need to use them, not just me. So.
Right. Cool stuff. Okay, let's start.
Okay.
Hi, I'm Camila, and welcome to Humans of AI interview series.
Thank you for having me.
Thank you for being here, Nick. So with Humans of AI, just to explain to our guests, we are trying to demystify what AI is and what is not, and we try to make this whole concept a bit more approachable and digestible. So today we are welcoming you. You are the Associate Professor of Engineering Science in the Oxford Robotics Institute and at the University of Oxford, and a tutorial fellow at Pembroke College. So,
yep.
Well done. So could you tell us a bit about your background? How did you arrive to where you are right now?
Yep. So I think it goes back to being like a 16, 17-year-old and not knowing what to do with my life, or not doing what to do with university. So I was good at maths and physics and that sort of stuff. But it was a bit weird. So I used to play in the school orchestra, and every year we would play at a ceremony where there was a booklet that was handed out that was all the destinations that people went to at university. And everyone was doing like maths, English, physics, psychology, blah, blah. So that's really boring. I want to do something that is different from those things. So I got a book of university degrees. So back then there was like books published with the list of subjects you could study. And I would go through that, and I saw artificial intelligence. Like that sounds ridiculous. That's not a real thing. And so I applied for that. I had no idea what it was. I just said, that sounds cool. I had no idea what I'd study and how it would be assessed, but I just started applying for those courses, and I ended up on a degree at the University of Birmingham doing computer science and artificial intelligence. But then back then it's not like it is today. So now the reason you're doing this is because everyone knows what AI is, everyone's interested in AI.
Yeah, exactly.
Back then it was, give me 1 second, I'm going to close my window because there's a lot of noise outside.
It's okay. I have a like very loud neighbor's child, so you probably can hear it. Not yet, but you will hear it.
Okay, that's probably my child. So it was crazy. So I was doing it, and I had to explain, hundreds of times to my grandparents what it was. Like when back then I had hair and I got hairdressed, and they say, "What do you do?" I said, "Oh, I'm studying artificial intelligence," and some of them thought I was a spy, kind of intelligence like James Bond.
Okay.
And so, I studied the AI at university. And then, again, there was very few jobs that used AI back then. There was some in defense, maybe a little bit in things like logistics and optimization, but this was back in end of the 90s. And so I stayed on and did a PhD because I didn't really know what else to do, and university had been kind to me. And so I was sponsored by Sony Computer Entertainment. I did video game AI. So that was the other big use of AI, really, that people were kind of still putting into video games.
And you didn't want to go into a commercial path, like staying with Sony, or they didn't give you the job?
After that, they didn't give me. Did they give me a job? No, they didn't. I interviewed for them. I was actually a terrible. So game AI, you have to be an amazing programmer. So games programmers are kind of some of the best programmers out there.
Yeah.
And actually, my programming wasn't great. Wasn't good enough to go into that kind of area. I did do a bunch of interviews. I also interviewed for kind of academic jobs, and actually ended up kind of halfway in between at a place called Media Lab Europe, which was a spin out of MIT Media Lab. This was in Dublin, and they did a kind of mixture of sort of applied computer science, a mixture of sort of CS, art, AI, and all these kind of things.
Yeah.
But this was doing very vague AI concepts. We looked at things like common sense computing. So how could you make a device have something like common sense like a human would have? Whether that was just an algorithm, whether that was kind of, we looked at things like predictive text on mobile phones. So back when you have to press the same button 3 times to get a letter, How could you speed up things like that? So we looked to kind of
Right.
optimize
But
it.
it was mainly on like rule based, right? Like it was not very
It was a
interesting.
mixture of, I mean, everything I've done in my career has been a mixture of rules and statistics. So, all machine learning is rules and statistics done in a particular way. So I tend to look at things like that. But that was, then I got an email from my old PhD supervisor who said, oh, we've got this crazy project about programming robots and making a robot. The idea was to make a robot that was kind of growing like a child, that would learn like a child, and be very kind of creative and kind of developmental. And they're like, none of us here know how to really program robots. And you were quite good with video games, or a bit like robots, you should come and do that. And then that was the kind of the start of me doing robots. And then since then, I've always applied AI to, I think, what you call physical or situated decision making. So things that actually have a body of some sort, whether it's a robot or a video game character.
Yes.
And I've tried to solve problems in their worlds.
Right.
So that kind of started there and went off. So it was interesting because the person that hired me wouldn't let me do their robotics course at undergrad level because my grades weren't good enough. But
oh no!
I finally got to go back and play robots. And then
you showed him now.
and then so from there on, I did academic things and studied various forms of planning and AI and learning all sorts of stuff and.
So why do you think there is a suddenly, like over the past decade or so, like a huge hype on robotics? Like there is this robotics revolution. Like you have obviously, like in the media, you have the Boston Dynamics and all the, let's say, intelligent robots.
It's interesting. I'm not. So I think there's a hype around kind of very far-fetched robots. I think there isn't such a huge hype on robotics as there is on kind of more general AI, on computer vision and machine learning. Okay. I think in some ways what looked like a robotics peak about 10 years ago is starting to pass, but now it's quite good because robotics actually is becoming very just every day. You know, people don't question that the automation is now an important thing. And logistics, deliveries, huge amounts of. So I mean, historically it was manufacturing, it was robots working in controlled worlds. I think there's been a lot of interesting developments in things like probabilistic algorithms for robots that allowed us as a field in the kind of late, I guess in the 90s, to make robots that operated in more dynamic environments, so places where you could let humans operate in. And that led to probably a kind of rise in robotics in logistics and things like that. It also led to the original kind of self-driving or autonomous vehicle.
Exactly. Exactly.
So I'm not sure there is I don't think there is a huge hype around robotics. There's lots of cool people like robot videos, right? People like watching videos of Atlas doing backflips and quadrupeds.
Yes. That's a hype. But as I don't know, like at what stage they are right now, but until recently, it's been basically like at least the Boston Dynamics. It's like human operated operating with a joystick. This creature, right? So how do you think the robotics will evolve, and how will it take to like make them truly intelligent?
Yeah, that's a big leap. So I wouldn't say truly intelligent because we don't know what intelligence is, right? Intelligence is not a goal for me. So I like the idea of making robots useful for a particular task, and AI in general and robotics probably more so should always be focused on a task. Right?
Narrow AI.
Yeah, exactly. We should be thinking, let's build a system that allows us to monitor the radioactivity levels in this nuclear waste. Let's build a system that can monitor fish stocks in the Atlantic, right? There should be a particular task, and then you can say, how can I make a robot more capable of that, more robust, more reliable, and more autonomous, right? So you want the system to be able to do more of that without a human literally contrailing every
exactly, with the joystick. And what do you think are the biggest challenges around that?
I mean, there's endless challenges. So there are kind of 3 dimensions to robotics typically. So you have perception, so allowing the robot to work out what's around it and where it is. There's action. So how do you turn your decisions into actual physical changes in the environment? And then you've got the kind of decision-making part, which is given what I perceive, how do I decide what to do next? So you've got kind of these three categories. And there are big challenges, kind of academic challenges in each part. And what you see is these advance at different rates. So actually kind of the control and action part is reasonably mature. So you can see, so the robots you're talking about that you can control with joysticks and they can do fancy things, they exist and they can do really, really amazing things.
Yeah.
But we don't have the perception or the decision-making to control them autonomously. So in some sense, we've got the bodies that are ready to be autonomous.
Yeah.
So the major challenges, at least from my perspective, lie in the decision-making. So how those robots can decide what to do next, whether that's how to move their joints in a larger way or how to decide what to do for the next hour or the next week, and how to perceive the environment. So robotics has always been, or interesting kind of autonomous robotics has always been sort of hamstrung or slowed down by the availability of reliable perception algorithms. So if you want a robot that's going to, classic example is a robot tidying up your house or putting your shopping away. That's the dream, that's a sci-fi dream. But having an autonomous system that can reliably recognize and sort of segment in 3D every item in your home is still, you know.
Yeah. Like if we look at the Roomba right now, it's not really smart.
No, but that's another great example of very, very task-specific, cheap, robust robot, right? So it does what it does. It doesn't do it incredibly efficiently, and it doesn't do it incredibly efficiently because it's limited by perception. So the body is there. We know the algorithms required to get it to hoover every bit of or to vacuum clean every bit of your floor. But the expensive bit was working out where it is in your home. And now some companies, kind of Dyson, for example, have been building robots that can do that. But still, it's very task specific. So it's great at cleaning, but it's not going to cook for you.
Yeah. Although I saw some pizza robot. I forgot. I think it was like in Italian invention, but I think it wasn't. They tried to commercialize it, but
this pizza robot.
Pizza robot, yeah. Okay. He was making a pizza. Cool. So let's talk about the other very related issue, which is Uncanny Valley, right? It's like how do you think humans will we try to stay away from making robots look like humans, or because of this phenomenon are we trying to keep the distinction? And maybe explain what it means for the audience.
Okay, so Uncanny Valley is the description of a phenomena, sort of psychological phenomena, where it describes people's reactions to devices that look increasingly human. Yeah. So if you show people pictures of humans, they say, yes, we like looking at humans. And if you show people looking at robots, they're like, they're okay. And as you get closer and closer to the thing becoming human, they're like, oh, we like it more and more and more. And then you get too close and that kind of rating drops massively. People go, oh, it's uncannily like human. But it makes us uncomfortable. I don't know. So I guess I think back to my previous statement about robotics now being task specific. So if you start thinking about building, I guess I'd say I'm not interested in general artificial intelligence, and I'm not interested in building robots that look like humans and act like humans. I'd love them to exist. I think that's super interesting in many ways. But as a working scientist, I find that the problems there are very ill-defined. Yeah. And I'd much rather solve kind of, again, task-specific problems. Take this thing, make it better at doing specific tasks. And I like the sort of Star Wars vision of robots. And if you think, I mean, this is my geeky personality and my particular age and upbringing. But in Star Wars, when they go to an environment, there's always different shapes and sizes of robots, all doing kind of fairly specific tasks. You've got these little boxy things on wheels, and you've got things with long legs and long arms, and they're all kind of specialized. And so I guess I'd like to see us building robots that have kind of clearly defined scopes of functionality and use them for those purposes. And so by that nature, they won't necessarily look like humans because they'll look like the right thing. Yeah, they'll look like the thing for their task. I think that doesn't mean that we shouldn't. So there's some interesting work that goes around in building and controlling bipedal robots, quadrupedal robots with 2 or 4 legs, and those are kind of useful because I would like to.
We lost you, Nick. I knew it. Bloody internet.
I mean, it happens all the time.
No, that video. There is no video. Yeah.
There we go.
Okay. Happens all the time.
And it will happen again, I'm sure.
Yeah.
So where do we get to?
So we were talking about specific. Oh yeah, robots with legs.
Oh, okay. So I think I was sort of saying that even though I'm not interested in I guess robots that specifically look like humans, I think because we want to put robots in human environments, there are lots of environments that are designed around our physical form, and so I can see a world in which we build robots with arms and legs in a configuration a bit like a human, because it's the best way of opening cupboards, right? If you want a robot that works in your house, puts your shopping away, they have to be able to open cupboards. If you want a robot that works on an oil rig, checking the pressure of vessels, or checking condition of pipes, they have to go upstairs and open doors. So these things would naturally emerge from the design, I think.
I forgot the name of the company, but the very famous one is it folds the clothes. It has like two hands.
Is it a PR2? So it's a wheeled robot and it folds towels. I think that's probably University of Berkeley. They've done loads of cool manipulation stuff with
nice.
Or Stanford. Cool. I always get them mixed up. I shouldn't do that.
Okay, I will cut it up. No, I won't. So you also said that using AI to control robots is hard at the moment. So why do you think it's a case? Is it to do with the level of understanding our complexity of human language and translating it to machines, or there's something else which is bigger?
I think so. The problem with using, so the reason that AI is hard in robotics is the same. The reason that AI is hard in any, I think, product or tool that has to operate in a kind of in an unconstrained or a real world environment. So what we do when we build AI systems, what everybody does pretty much, is they make some kind of model, some kind of software model and some kind of mathematical model. And that model is a way of writing down your assumptions about how the world is going to behave. And sometimes you are very aware of the assumptions you write down, and sometimes you're not. So it might be that, for example, if I'm writing software for an autonomous vehicle, I might assume that there are lanes, and I will write the algorithm such that it keeps within the lanes, and I've got 2 lane markers, and that's how I write my code. Or if I'm writing some face processing image, I make assumptions about the number of eyes people have got, and I use that in my model. Or I train my machine learning system by giving it lots of pictures of people without glasses, and then I want it to work on people with glasses. Anyway, I think there's lots of examples like this where people encode their own either biases or just the sensible modeling assumptions into larger problems. And we do that in academic AI because, and then we evaluate our models on data sets or on problems where the data matches the model. So I make some assumptions, I write my software based on those assumptions, and I test it in worlds that follow those assumptions. But the real world will not follow those assumptions in various ways. So when you work with robotics, if you want to put robots into, so we've done work putting robots into care homes, into offices. We're working with companies that are putting robots into supermarkets. Your assumptions about the way the world behaves will not match the way the world actually behaves when the robot goes there. It might be that the lighting levels aren't as constant as you expected. It might be that the way people move is unpredictable.
Yeah, we are unpredictable.
So it's not necessarily that it's unpredictable. It could be just so far beyond what you've expected that even a low, it makes it hard because it's harder to make assumptions about the way the world will operate. And when you're writing any software or designing anything for automation, you need to understand how the world will behave when your system acts on it. And so if it doesn't behave in the way you expect, then your program doesn't do what you expect. Therefore, your robot or your software doesn't work very well. And so robots are just a great example of that, because the world that if you want to build a kind of an autonomous robot of the kinds we've sort of been talking about, that robot both has to move reliably in space and it has to make higher level decisions about what it's going to do. And so there are so many parts to that puzzle, whether it's, does the robot recognize the thing in front of it? Can it predict how the person's going to move, what the person's going to say? If it's talking to a human, all those things, in every one of those things will introduce some kind of error, some kind of unmodeled assumption that these things compile or cascade, and you end up with kind of the robot doing very strange things, but only because each of your models was just a little bit wrong. And each of those models being wrong on its own is not really a problem, but when they're all kind of, when all the wrongness gets aligned, you end up in trouble. I don't know if that's really captured it. Does that make sense?
Let's see. We'll receive questions after when we publish it.
Okay.
Yeah, it seems like you explained it. So another interesting angle I know you are exploring is long-term autonomy. So robots operating for weeks or months. So why do you think it's an interesting problem?
Well, okay, I think there's maybe two angles to it. So one is in terms of kind of applications of robotics. I think it's the next sort of stage. So currently robots are still a novelty, and if you put a robot into at least the kind of sort of autonomous robots that we develop, you put those into a kind of an industrial setting or a workplace, it's kind of exciting, and they'll do something limited typically, unless we're talking about like factory or warehouse automation, which is a different issue. But if you wanted to have a robot that, say, operated on a solar farm and inspected the panels every day, or you wanted to have a robot, serving meals in a hospital or delivering meals in a hospital, they have to work autonomously and they have to work constantly. So it should be just like buying a printer or a monitor. You should buy this electronic device and it should work for a long period of time. And actually, a lot of the kind of higher level AI capabilities that we put on robots have never been tested in those kind of settings. Things like, so there's a real interest to have this kind of, to deliver on the robot hype that you mentioned at the start, to put robots into lots of interesting settings. But very few tests have been done on how those robots can perform robustly over long periods of time. And the other thing that's interesting, perhaps more academically, is that we know that for example, machine learning systems perform better if they have more data. And that's true of many. Oh, sorry. Did it pause? Are we still here?
We are still here, but I kind of see you in a weird, like you're slow and fast.
Oh dear. Do you want me to go back? Where did we get to?
No. I can hear you. It's just
okay.
the vision. But anyway, you continue. Yeah.
Okay. Where were we? So So one, basically, we need our robots to operate for long periods of time, even if they're autonomous. Whereas, like, kind of robots on a car production line operate for infinite time, but they don't do anything particularly interesting from an autonomy perspective. We want robots that are doing interesting autonomy, operating for long periods of time in these unpredictable environments. We talked about why AI on robots is hard. Doing that kind of, applying AI over weeks and months of operation on an autonomous robot just compounds that difficulty, because the amount of the world you see means that you're bound to start running into these things that you hadn't expected in some way or another. And so that becomes interesting. So AI systems typically are trained on some amount of data, whether that's AI systems being explicitly trained through machine learning, or whether that's just a developer using that data to run tests on their systems. And so there's a really interesting academic challenge about systems that act and learn as they act. So a robot, the example we use a lot is having a robot that's operating in some office environment, and there's a canteen, and it starts off by planning the shortest path between two locations, and it always follows that shortest path. And then it starts to discover that when it tries to go through the canteen area at 1 o'clock, it's harder for it to move through that environment because there's more people, there's more uncertainty, there's more dynamics. And so we'd want our robot to learn that at that particular time of day, it should take a different route. But of course, those different routes will also have different kind of problems. but only by experiencing the world over long periods of time can the robot gather the data to train its algorithms or to learn to perform better at those tasks.
Yeah.
So one of the interesting things around kind of AI for long-term autonomy is that the robot acts as a device that gathers its own data and should be able to improve its performance, become more robust, and have better performance by operating for longer. So there's this kind of virtuous circle. The longer a robot operates for, it should get better at doing its task. If it gets better at doing its task, it should then be able to operate for even longer. So that kind of virtuous cycle is one of the things that I'm quite excited about, trying to get robots into environments for long enough that we can get enough data so they get better at doing whatever task it is that they do.
And so do you have any examples of like real working robots which are like operating for long already? And
so in our research, we've put robots into, we had a robot in an office environment, or a couple of office environments where they were there for a couple of months at a time, operating where they would manage their own battery level. They would learn about how to navigate through the space. And so these examples of parts of the environment becoming impassable at certain times of day, we had a lot. So we had a robot navigating through an open plan office. And the robot used to drive down this corridor, or not a corridor, like a gap behind a bunch of desks. And when it did that during kind of most working hours, it was easy to navigate because everyone was tucked into their desks typing away. And then at lunchtime, people would stand up, push their chairs back, and the robot wouldn't be able to get through the same environment. And that was kind of predictable patterns that our robots could learn. But we had a robot in that environment doing lots of things. The robot would look at people's desks and look at kind of surfaces and shelves just to learn what was there.
mm-hmm.
So by being in that environment, the robot could get lots of data about the kinds of patterns that reoccurred. So it would learn both the dynamics, how people moved around, but also what objects typically appeared. So the robot was able to detect things like mugs, monitors, laptops, things that it started to see regularly by detecting kind of the similar shapes and visual patterns. It was also able to detect things that were kind of novel because it operated for a long time. It became, in some ways, kind of not immune. I can't remember what the right word is. It was able to kind of say, look, these are things I've seen before. And we had a nice occurrence kind of week before Christmas. The office manager put a tiny Christmas tree on everyone's desk. And in our logs, we saw the robot kind of flagging this up as, look, there's this new thing that's appeared, and it's appeared everywhere. So it was able to see this thing had appeared everywhere. But that's not by saying, you should look for Christmas trees. That's by saying you're going to operate in a long term, you're going to operate over the long term in an environment, and you should collect, you're collecting visual data, and you should process that data with particular statistical algorithms. But that gives you nice properties. So we've done stuff from a kind of research perspective there, also in security, also in we've had a robot acting as a kind of guide or a information terminal in a care home. And in all those cases, the robot would do things. So in the care home, we had some work with partners at the University of Lincoln where the robot would learn when and where people used it. So you want a robot to go around and pass information to the residents of the care home, but we didn't know where and when they were likely to use the robot. And so we tracked people interacting. This robot had a touch screen, and so we tracked people touching the screen, and then the robot could predict over time where the best places to go to meet people were. So that robot got better at passing on information because it was able to model when people were more interested in using it. So those are sort of, I guess, fairly fundamental ideas. Like you learn from experience, you then plan, decide how to act to maximize the value you get in that.
Are you planning to, or like is university planning to commercialize any of those findings?
So typically not via the university. So we're working with a bunch of companies that are interested in using some of these ideas. So one bit of work at the moment we're doing with Bossa Nova Robotics. So Bossa Nova have been putting robots into Walmart stores in the US. They're working with a couple of companies in the UK. They're in hundreds of Walmart stores now, and they've got these robots that scan shelves. This is a kind of classic example of the kind of things we're interested in. So the robots go up the shelves, scanning kind of a light at the shelf. They move along. But if they encounter a person, they have to stop because the sensors, the cameras have huge bright lights, and if they go around you and shine the light at you, it's not very pleasant. And so they stop, and then they either have to they can't carry on down the shelf, and sometimes the shelves, the alleyways might be blocked. Maybe there's lots of people buying chocolate because it's Easter or something that gets stuck. So we can apply the same ideas to have the robot for a particular store learn the dynamics of that store in order to be more efficient at scanning the shelves in a limited amount of time. So you only want to have the robot on the shop floor for, say, an hour. And so you have to plan which shelves you can visit in that hour in order to maximize
Off peak,
the
yeah.
amount of work you can do.
And
And so, sorry.
Go on, sorry.
I was just going to say, we don't think about typically taking the kind of whole robot that we've been using and doing.
No, but some findings.
Some chunk of the algorithm.
But is it for like expiring products, or how do you want to use it for? When you scan
the shelf scanning robots. So they provide data to the supermarket operators that can then look at. They do a couple of things. They look at stock levels, and they also look at checking the alignment between prices and. So they can see the price that's printed on the barcode and compare that to what they've got in their data set. They can also check that the barcode and the price matches the product. So they're doing a bunch of AI to process the different images they're getting.
That's very cool.
So that's one example of some things we're doing.
Yeah. So really, really cool field to work on. So let's talk about another of your research topics, the mission planning for robots under uncertainty. So why do you think it's interesting? It's worth investing time and resources.
Well, it's exactly the problem we just talked about. So kind of traditional or historically planning. So this is the planning. I should probably say the planning problem is deciding what to do next. And you model the world of a robot in terms of actions the robot can perform. That might be driving between two locations. That might be picking something up. That might be turning a light on if you're about to scan a shelf in the supermarket example. And then you describe the kind of state of the world between those actions. So much of AI uses this notion of state. So state describes kind of a snapshot of the world. It might be the robot's location. It might be its battery level. It might be where people are around it. And kind of sort of historically, Karen, explain. Planning is then working out a sequence of actions that allows the robot to achieve some kind of goal. So that goal might be to have scanned all the shelves in the supermarket, or delivered a meal to a patient in a hospital, or scan some barrels in a storage facility or something. And you would give the robot the task. It would plan, execute the plan, and then come and get another task. And so the kind of long-term robots I mentioned earlier, they would have they have a long list of things they would need to do. They would take something off the list, they would plan for it, execute it, and do it again. So the planning is a key part of enabling autonomy in these robot systems. The thing that interests me there is that the actions that a robot performs, in most cases, do not have completely deterministic side effects. So it means if the robot performs so an action typically says, okay, if I drive from A to B, then I get to B. But in some cases, I drive from A to B and sometimes end up at C, and sometimes end up at D, and sometimes I don't leave A. And planning under uncertainty is a way of writing algorithms that can use the probabilities of these things happening to decide what to do next. And for me, it's a nice fit because when you have a robot that operates for long periods of time, it can actually generate its own statistics of operation. So the robot is actually trying, in the supermarket example, for example, to scan the bread aisle. And it tries to scan the bread aisle every day, and every day either succeeds or fails. And so you can then, over long periods of time, you can start collecting those statistics about success and failure. And that gives you an action or a model of an action that tells you how often you're going to succeed on a Monday and on a Tuesday and things like that. And so a lot of the work we do in my research group is about how can you come up with plans with those kinds of models? And how can you come up with plans that meet what we call probabilistic, or provide probabilistic guarantees? So there's a field of computer science called probabilistic verification that takes models and says with certainty that something will happen or not happen, or with some probability. So you might say with probability 0.9, my robot will scan the whole supermarket. And we're interested in creating algorithms that allow robots to come up with plans that give that kind of guarantee. So you can kind of think of it as a quality of service guarantee or something like that, that you could say, I want my robot to scan the whole supermarket every week with probability 0.99. And that's what I will sell to you as a business. I'll sell to you my performance guarantee, and you can use that to evaluate me. And as I get my data in, I can work out the right way of doing that such that I maximize performance.
In technology, like projects, you call it the definition of done.
Right. Yes.
Yeah. Cool. So let's talk a bit on a more controversial subject, if you're okay.
Okay.
So what's your take on using autonomous drones for military purposes? And how do you think we should regulate that?
It's clearly, so using AI in an aggressive capacity is clearly a bad idea. There are many reasons why that is. And I think there are a great number of people who are better qualified to talk about it than me. I mean, I'm a low-level algorithm person. I like building systems and programming them.
Don't underestimate yourself.
But I mean, I think it's fairly clear that there's a whole bunch of dangers around using AI to make life or death decisions. And a lot of those feed back into the question or the issues that I said earlier about models. So AI systems are very good at working on a particular task with a very clear set of inputs and outputs, right? That's what we always build, and that's how we know how to evaluate these systems. Any robot system, any system that uses data from the real world will at some point encounter input that it was not expecting, and may, if it's not correctly designed, may make bad decisions, or decisions we wouldn't want it to have made given the input if we saw that input. So that's the danger with autonomy in general. There's a chance that it will not be 100% reliable, and if that 100% reliable is then connected to a life or death decision, that seems like a really bad design choice to me.
And how do you think we can regulate that?
I think the same way that we regulate a bunch of other things that people, the same way we regulate chemical weapons, right? The same way those things happen. People make treaties. They say what can and can't be used in war, for example. It doesn't stop some people using them because there are bad people in the world, and they will go and do things even if you say they can't. But as with all these things, I guess what I'm quite against is regulating the basic research in this area. So along with other ideas around AI, I hope the idea of kind of regulating AI research at the level we're doing it now seems completely crazy to me, because
because when we can regulate it in our states or like in Europe, but then you have China and other countries which they have their own thing. So
I mean, every country will have different rules on how they interpret these things.
Exactly, and different saying of what is good and what's wrong.
I think I think there's also a key difference between fundamental research and applied research. So I think fundamental research should generally be allowed, unless it's kind of the stuff. Almost everything in AI in universities at the moment, and has been for a long time, is fundamental research on basic questions. In robotics, of course, that's slightly more applied because we work with physical platforms.
Yes.
But that produces new knowledge, and that new knowledge is important and it's groundbreaking. What people do with that knowledge is a little bit disconnected from how we do the research. And it's how it's applied that's the key place where regulation should be focused.
So how do you think we can use autonomous machines for global good? Like, there is this concept of universal basic income, where at some point we will reach the point where people no longer need to work if they choose not to. So what's your vision?
I can't say I have a vision on that level. That's very grand. I guess the first question: how can robots be used for good?
Yeah,
I think there's lots of great examples. I think agriculture is one of the places crying out for more automation. There's we can use robots to.
Sorry, can you hear the bloody? Okay, go on. Sorry.
Sorry. I mean, it would be worse if you were in the room. Have you got kids?
No, that's why.
Yeah. Okay, I've got two, and these noises are. It's fine.
Can you make some robots to count the babies down or something?
You've got iPads. You don't need robots.
But when they are before that time, where they can.
I think robotic childcare is a bad use of robots. I think that's certainly I think we can
Maybe
agree
that's something I should start thinking of.
Okay, so robots for good. I
Yes.
think things like agriculture would be is a great example. I think ecological monitoring, so monitoring the health of species, of how climate change is affecting the planet, being able to get data, reliable data over large spatial extents in places where people aren't going, is a great use of robotics. There's nice examples of places like the National Oceanography Center sending robots or kind of autonomous submarines under ice shelves to monitor the thickness, to look for new species under there. I think that's super useful. I think there's lots of great applications we can put robots to. The problem is funding those things is not where people make lots of money. People would rather build autonomous cars and delivery systems and warehouse systems. I think perhaps the positive thing about all that, they're all awesome uses of robotics, is that will develop the technology that we can then use to apply for more, apply that technology to social good when it's been made robust in a kind of more commercial market. So yeah, I'm not really giving a super good answer to that, but I think
it's good for the first bit of the two questions actually, and the second question was about the universal basic income. So do you have any views on that? Or
not professionally? I think it's so far outside of
and personally
I think it's a really exciting idea, but I think I don't, coming on here as a robotics academic, I don't think I'm qualified to make statements about that. I mean, I think the idea that robots can take labor away from humans, I think is interesting, and that the transition to an economy where more and more is automated can be very challenging for people whose jobs are in risk of automation. So that's certainly very clear. I think the governments across the world should be thinking very hard about how to manage the transition to a more automated society, because it will come. In what order which things get automated, I think it's very unclear, but it's clear that lots of things will get automated, I think. And people will lose their jobs, and yes, other jobs will get created. Exactly. But it won't be overnight. There won't be a snap of your fingers and things will be arranged. There will be a long process of change, and that change could be very painful for people who are disenfranchised in society, or people who will become disenfranchised by those processes. So I think it would be great for people to understand that process and to understand the effect of automation. But at the moment, given that everyone's just losing their jobs due to COVID,
quite different challenge. Yeah. So how do you think people can learn more on robotics, in terms of like, if someone is interested to maybe wrong question. So for someone who is very new to this and finds it interesting, where do you think they should go for resources? Where they should go for something which is like fact-based?
It's a good question. So I think there are some good online courses for kind of learning to program robots. So there's a whole range of things. When you say kind of robots, there's a huge range of things. So people might be interested in mechanical engineering, actually physically building robots, or people might be interested in what it takes to program a kind of fully autonomous robot and what the AI models and statistics we use are. And those are very, very different skill sets and different paths. There are a couple of online courses run either kind of Coursera or edX or someone like that, does like a full-blown how to program an autonomous vehicle, and that kind of covers everything from localization, control, decision making. Those kind of things are super interesting. There's a book called Probabilistic Robotics, which is like one of the bibles of the kind of world that I operate in. It covers a huge range of the key algorithms and math that people use. So just reading that will get you into this kind of world of how to do some of these things. But it won't address some of the other questions about humanoid robotics or good uses of robots. That's a very different angle. I can't really necessarily, I don't know, that's just experience and understanding. I think for me, in all of this kind of world of AI hype, if people understand what actual artificial intelligence is. I mean,
Exactly.
there isn't one thing. AI is a field, right? AI is a field like physics. You don't just understand physics. You have to realize there are different parts of physics, whether it's particle physics or space or whatever.
Mm-hmm.
So just like AI. So I think in this area in general, it's important that people pick up basic knowledge and basic familiarity with various aspects of AI, whether it's machine learning or optimization or natural language processing, so that they can have kind of rational, reasoned dialogues around this space of this topic.
Yeah. So what do you think, or what kind of other AI related hype do you see portrayed by, like, spread by media?
I'm not sure it's just media, actually. It's I think it's the hype that AI can solve all problems and that everything is better when you add AI.
Yes. I'm sure it's better when you add AI to evaluate your company.
Yeah, no, I was going to say there was a really interesting statistic about the proportion of companies that had AI in their pitches but didn't actually have it. Yeah. So absolutely, I think that stuff is scary. I think it's great for for graduates, for people who have done AI and training. They're all going out and getting jobs. So it's good for them. But what was the question?
Any other AI related hype?
Yeah. I mean, almost everything AI is hype, right? At the moment. There are people that are putting it to amazing use in products and in companies and stuff. I worry that people use AI as a blanket term for stuff they don't understand, and it's just a bit dangerous. So it makes it sound, there's been a number of AI kind of bubbles that have burst over the years, and there'll probably be this bubble will burst at some point because people will be like, well, you've spent 5 years talking about AI and nothing's really changed. I don't see anything fancy happening. But in reality, behind the scenes, algorithms that predict things, that optimize things, are being run in increasingly large numbers of places. So, AI as a small instances of task-specific AI is just creeping in everywhere. And that's great. But the hype of AI as the label AI is out of control.
Sure.
But whether it's the media, whether it's business, whether it's academic.
But it's probably like trends, right? You had some years ago, you had the big data. Some years, like few years ago, it was like blockchain, crypto. Now we have AI. What's next, do you think?
Well, I think it's the combination of all three. That's the big. There are certainly people that do all three of those things at once, or at least say they do. I don't know. I think we'll just probably go back to just regular computing. It's all computing. It's all algorithms, and that's exciting. And that's stuff that with people in the UK, people across the world are great at. Computing is a thing that everyone should understand. People should learn how to program. They should learn kind of fundamental discrete maths and decision making, and that will help cure some of the hype if everyone is literate in those topics.
Right. Yeah, like you said, like you were not good enough for grammar. I'm not old, but when I was younger, like we were not encouraged to learn to program. I can do easy, like the HTML, CSS, that kind of stuff. I can do it, but I never really learned.
That's hard. That's
not really. And I can do the I was saying, shit, I already put CSS. No CSS, one said SLL, the security licenses. Anyway, I'm bragging. So I never really learned how to code, and I see how limiting, how much is of limit for me. Because you can build things from nothing, but now you have those platforms which promise you, let's say, the code-free platforms. Like you can program without actually understanding how to code. So people are more, let's say, flexible on building things. And are there any like soft like platforms or areas where you where people can learn how to program robots, like play with robots. Like, for example, I remember there is a really cool company focused on teaching kids how to program. It's called Tech Will Save the World.
Right.
Yeah, and you have like those small robots. You have everything is colorful and beautiful for kids, and they learn how to program. So you have the Raspberry Pi, and you can do cool things around it. Is there anything for like older people?
I actually just kind of Raspberry Pi, Arduino, kind of building things that interact with the real world is always very interesting. But I Lego. I mean, Lego has all sorts of cool things, right? You can buy Lego robots that you can program, and I don't think you're ever too old for Lego. No, I mean, you can go and pick up a drones and all sorts of stuff. There's loads of things out there that you can learn to program with, and because of the way the community is, people will have built a Python interface to it, or will have worked out how to kind of hack into the firmware and use it. So almost anything, I think if you just go on Amazon, you'll find something you could learn to program with. But I mean, starting simple is the key with programming. You shouldn't pick up something like that without any programming experience. I think starting and there are so many online resources now just to learn how to program and get stuck into that.
But that's the problem, because there are so many people get confused which one to choose first, and they get discouraged.
Yeah, but also you just have to pick one and do it. I think it's there's not a lot to say there. I think it's just a question of finding stuff that fits with your personality. That some people like to have kind of be sort of fed a series of small problems that they solve. Other people like being given a bunch of kind of solutions and told to go and apply them. So I think finding the thing that works for you. I mean, the thing I've seen over many years of teaching students to program and teaching them and kind of supervising kind of AI projects, robotics projects, is the students that do best are the students that are excited about what they're doing. And that might be people that are excited about learning a new programming language, or it might be students who are excited about the application they're building, the use they're applying this stuff to. So I guess my advice for anyone getting into anything is to find a way of doing it that you're excited by, that you get up in the morning and go, oh, I can't wait to program today because I'm closer to making my bat and ball game, or I'm closer to
choosing a project, right? Like
something. But it has to be something that motivates you, not
Cool. Awesome. You were fast. I thought you would take an hour, and we still haven't even reached the cutoff time from Zoom.
The Zoom limit. Why?
Oh, is there? What? Are we still recording? Yes. I thought yes. I think there was a 40 minutes. Yeah. Anyway.
But maybe because I left.
Oh, maybe.
when the connection went down.
Maybe. Okay, so is there any other like area which we haven't discussed and you find interesting?
I don't know. I mean, I find lots of things interesting because I'm geeky. I think I'm more willing to answer I quite like random questions. If there's bits that you think you'd like to touch on that I haven't, I mean, I sort of dodged a bunch of the questions that I didn't want to discuss anyway.
Exactly. You didn't want to tell me more on universal basic income.
I think it's a great idea. I mean, I just don't. I want to see more results that back it up as a method that does what it says it does. I'm a scientist.
Some countries already started like tests with it, like Sweden, I think, or somewhere in Scandinavia. But it's a bit in the future. Cool. So is there anything you would love to?
No, probably
no, that's it.
No. Is there anything else you want to ask me? Is there anything else you want to know about AI? Is there any bit in your quest to demystify AI? Is there bits of AI that are still mystified?
Maybe what do you So give me an example of like really, really smart, narrow type of AI which you either worked with or heard of.
Smart, narrow AI. So I think one of the most one of the things that I think people get really excited about in smart, narrow AI, an example that I've seen is some technology that came out of the mobile robotics group at Oxford. So they span out into Oxbotica, and they do a lot of work on self-driving cars.
Mm-hmm.
They do a lot of work from cameras. They use cameras as one of their main methods of localization. And what they do is you train these systems to be able to match two images. So you have a kind of map or an experience, which is the thing you've seen in the past. Last time you drove down here, the road looked like this. And you've got a live image that says, this is what my camera's showing me. And you try and match these things up.
Mm-hmm.
And one of the problems they have is your memories only look, your experiences of this environment only look like that they did when you were there. But if you go back to the kind of things we were talking about earlier, the external world can generate any image to throw at you, because it might rain, it might snow, there might be 10 buses there for some weird reason. You've just not seen these things.
Yeah.
And so one of the big challenges they have is, how do you take an input image and make it match your background image? And so there's been some really interesting developments about using neural networks to alter the images so they match better. And they might use that either at runtime to try and match the images, or at training time to generate training data that can cover a wider range of circumstances. So if I can put more training data into my algorithm, it can recognize new situations, even if I've never actually seen them before. And so this group built algorithms that were able to kind of hallucinate new scenes. So you said, okay, look, here's my image of Oxford, and now I'm going down this environment and it's snowing. So that their algorithm or their network could then hallucinate what the first image would look like when it's snowing, so it can match better across the others. So it's very narrow. It's about transferring weather conditions, effectively, or lighting conditions, from a kind of a training set to a test set. But it looks incredibly realistic. So it's able to generate pictures that you give it an input of a kind of normal scene, and it will show you what that scene looks like under snow or under wet weather or in the dark. And when you do that, it'll hallucinate lampposts and all sorts of stuff.
That's so cool.
And so it's very, very narrow. It solves one problem, but it's applied to a really good use case. So there's lots and lots of examples.
It's kind of reminds me, I think it's quite different, but reminds me of the project that I've seen the other day on Hacker News, where the guy basically created like a algorithm where he was moving. It was like all real time. I don't know if you've seen it. It was moving and it was cutting him off from the scene. So he was, so he was like in a room and he was like basically vanishing.
So convolutional neural networks and various iterations of these things have done amazing things. So I think visual processing is now a field that's so advanced that we shouldn't trust anything we see ever.
Yes,
because
exactly.
computers can do
yeah. And another like cool startup I know, they are called, I forgot the name. I forgot the name. Anyway, so basically they are trying to use the like deep fake in a way, to create like different images of people, and like change the way we speak, right? So for example, if someone is if you have a message in English and you want to have the same person speaking in French, they are just like
changing the way the lips move and
exactly. And it's all, let's say, what they claim AI real time and things, but I forgot the name. Okay, and maybe the subject we should, or like the angle we should talk about is, how do you see, or if you see any cool developments around robotics and AI within the current situation, which is coronavirus. Have you heard of it? Yeah.
So I think there's lots of good. I've certainly seen lots of interesting, either kind of demos or applications of robots in for Corona. I think one of the mainstream things we're seeing is robots for cleaning. So there's a couple of companies doing robots doing kind of UV cleaning. So they go into a space and they use UV light to clean it out, and that's a super interesting application and problem, because how do you know? It goes back exactly to the vacuum cleaner. How do you know you covered all the space? because you can't see a vacuum cleaner can't see what it's sucking up, a cleaning robot can't see what it's shining UV at. So you have to have some certainty that you've cleaned correctly. So I think there's really interesting planning problems and uncertain planning problems, which are things I like in that kind of world. I saw some really cool kind of drone delivery services and things like that. So how do you get packages to people in the 10th floor without going through the environment? And so using drones to go up the sides of buildings, all that's kind of cool. There's even some trials in the US now of using drones for medical delivery beyond line of sight through populated airspace, which hasn't been possible before.
Wow.
So excuse me, I think just as kind of COVID is causing us to reassess or change the way we do things, I think it's allowing automation to be brought into areas where it's necessary sooner rather than later. So yeah, delivery, certainly we're seeing more there. Cleaning, we're seeing more there. There's one of the professors called Perla in our institute is using she 3D prints robot muscles and robot skin and does things like that. But she's now 3D printing models of the lungs to help people study how lungs change with the use of ventilators. So we know that sort of extended use of ventilators is damaging people's lungs. And we want to study, or people want to study the effects they're having on kind of mock-ups. And so the kind of approaches she takes to printing robot muscles and robot skin can be used to print kind of very detailed models of lungs. So there's kind of all different angles of robotics that's being brought into to deal with COVID in different ways.
I really like it's what's the name, like a drone company called Zipline, and they are delivering blood, right, to very remote places. That's really
that's the same US example that I was thinking of. It's that was brilliant.
Anything else?
No, I think that's about it. I mean,
everything else is fraud.
That's not true. And robots in space is the other super cool thing. So I mean, we saw the SpaceX aborted launch yesterday, but
Saturday. I know.
Yeah, but I think robots for space. The coolest application of autonomy and long-term autonomy, the longest autonomous robot doing interesting things that I know of are the Mars rovers, Spirit and Opportunity. They're incredible, and they are autonomous. You can't remote control a robot at that distance, and so they have a very interesting paradigm of what we'd call shared autonomy or human-in-the-loop autonomy, where the system comes up with a plan that's then kind of run by the scientists on Earth, and they approve it, and then that mission plan is sent off to the robot, and the robot kind of and executes it. And these, they're doing autonomous science very slowly, but it's another super cool application of robotics. And I think the future of space exploration, space habitation, whatever we're going to do, will be heavily dominated by robotics and AI.
And do you think it will take us long
to do what?
To move to Mars or to inhabit the Mars?
Again, I'm not. That's not my area. I can't comment on that. I mean, clearly, it will take us a long time. How long? Who knows? But we haven't got people on the moon, so Mars is a long way away, both temporally and physically.
True. Okay, I think you've told enough. You said enough. Don't worry, I will, when we publish it, I hope there will be lots of questions. So if someone has any questions or wants to reach out to you, which one is the best channel, and how can they find you? Apart from going to Oxford and asking for Nick.
Yeah, they can't do that because none of us are there. Twitter.
No.
Twitter is probably best because then it's public anyway. So I think if they tag me on Twitter somehow. Okay.
Is there any do you have any blog or any place where you publish your research?
I mean, there's my website has a ton of my published research, but it's academic stuff. That's not. I mean, we have an institute blog. So the Robotics Institute has a blog where there are things written by my students.
Okay.
But I don't know. There's not a single place where you could point someone to necessarily.
Okay.
I guess the either my website or the Robotics Institute website is a good place to go to start getting
I will
a
just
bit.
tag you on LinkedIn anyway, and on YouTube I will put the link. So if they want to find you, they will find you.
It's not hard to find me, to be fair.
Yeah. Awesome. So thanks so much for finding this time, and
It's all right.
I hope you liked it as well.
Well, yeah, it's been enjoyable. As you can tell, I quite like talking, so it's also good to talk to someone different. It's been a long time with only talking to
different.
Yeah.
So who do you talk to normally?
Well, I talked to the same 8 or 10 people for the last 2 months, so maybe 20. You know, I probably talked to 20 different people in 2 months. So
Okay.
make that 21. That's exciting.
Woohoo! Okay, awesome. Thanks so
All
much.
right.
Have a
Well,
lovely afternoon.
you too. Thanks for inviting me.
Thanks, Nick. Bye.
Bye.